Hi all, so this is question number 36 from GATE 2019. The question is from linear algebra and it says that M is a 3 cross 3 real symmetric matrix with eigenvalues 0, 2 and A. With respective eigenvectors this U equal to 4 comma B comma C transpose, and similarly V and W are eigenvectors. And then it gives us 4 statements and asks us to check which of these statements are true. So let's solve this question. So the first fact that we are going to use that for a real symmetric matrix distinct eigenvectors corresponding to distinct eigenvalues are orthogonal. Okay, so what this means, so we have this distinct eigenvalues 2 0 and 2, so these two vectors u and v must be orthogonal. So which is what this is, -4 plus 2b, this must be 0, this implies that b is equal to 2. And similarly we can check that this v inner product of v and w -1 plus 2 plus 0, this is equal to 1, right? And this is not equal to 0, right? So what this means, that the eigenvalue corresponding to v and w must be same. So this means that a is equal to 2. This a is the eigenvalue corresponding to this eigenvector w. And and we also have that u. Now this u and w must have inner product 0, right? So u and w have inner product 0 because the eigenvalues are different, and this means that b plus c plus 4 is equal to 0, right? And this means that b is equal to -6. So a plus b minus c is equal to, sorry, this is c equal to -6. So a plus b minus c is equal to 10. So first statement is true. Okay, now we are asked that the vector m this satisfies mx is equal to v plus w, and so we know that for second statement we know that mv is equal to 2v and mu is equal to 2u. Okay, so m of u plus v by 2 is equal to u plus v. And what is u plus v by 2? This is just, so u plus v by 2 is just this vector x. 0, 3 by 2, 1 by 2. Okay. So this is also true. Now this for statement 3, we can see that first for statement 3, first of all note that span of uv w is r cube, the whole vector space v. Okay, why is that? Because first of all, like, these three are linearly independent. How to check that? So first see that this v and w are linearly independent. This is easy to see because they are not like scalar multiples of each other. And u and v and w, u and v will be linearly independent. Why? Because they are eigenvectors corresponding to distinct eigenvalues. Okay. So u and v are linearly independent and u and w are linearly independent. So they are all pairwise linearly independent, and so they are all linearly independent. Okay. So this span of UVW is whole of R cube, and mx and it is saying that this d is any vector in R cube, then mx equal to d has a solution. What this means is that this, if we define m as a linear transformation from R cube to R cube, then this map is surjective. So this statement is saying that this map is surjective. But is this map surjective? It cannot be surjective because 0 is one of the so if the map is surjective, then it must be injective also, right? So it must be an isomorphism. But M cannot be an isomorphism because 0 is one of the eigenvalues, right? So it sends a non-zero vector to 0 vector, right? Mu is equal to 0 times u equal to 0. So it is not injective. So this statement is false. Okay. Now what is the trace of the matrix m square plus 2m is equal to so trace is just the sum of eigenvalues, right? And what is the eigenvalue? So let me write it. So fourth, eigenvalues of m square are 0, 2 square and 2 square, which is just 0, 4, 4. Eigenvalues of 2m are, it will be just the same eigenvalues, 0, 2 and 2. Okay. Now trace of m square plus 2m will be equal to trace of m square plus trace of 2m. I think it should be, no, it should be again 4 and 4, right? Because if lambda is v is an eigenvalue, so 2m v, this is equal to 2 lambda v, this is 2 lambda v. Okay, so if lambda is an eigenvalue of m, then 2 lambda is an eigenvalue of 2m. Okay, so what is the trace of this matrix? m square. This is sum of these eigenvalues, which is 8. And what is the trace of 2m? This is sum of these eigenvalues, which is again 8. So this is 16. So fourth statement is wrong, false. Okay, so option B is correct.